We see it every day, in our kitchens, collected in puddles, falling in rainstorms, and flowing from fountains. Water is all around us, so it's easy to take for granted. But water is the single most important nutrient for every form of life on our planet. This program is part of a series on human nutrition, the science of foods and the nutrients and substances in foods, their role in the human body, and the impact they have on our overall health. In this program, we explore water. We'll learn its chemistry and its nutrient functions in our bodies. We'll get recommendations for how much water we need in different situations, learn ways we can consume water, and explore the many sources of drinking water. So, what is water exactly? Water is the most abundant substance on Earth. It covers 3/4 of our planet. It's everywhere. On mountaintops, underground, and in the air. And everywhere that water is found, it exists in one of 3 physical states: solid, liquid, or gas. As its temperature goes up or down, water transforms from one state to another. We can drink water as liquid, lose some of it as a gas when breathing, and put it in a glass as a solid. A molecule of water is made up of 1 oxygen atom and 2 hydrogen atoms. These atoms have opposite charges that attract them to each other, like magnets. That attraction causes water molecules to form connections called hydrogen bonds. Because of these bonds, it takes a lot of energy to change water's temperature. It's slow to become solid. The thermometer's mercury has to sink all the way down to 32 degrees Fahrenheit, or 0 degrees Celsius before it freezes. And it's slow to heat up. It has to creep way up to 212 degrees Fahrenheit, or 100 degrees Celsius before it boils. So large bodies of water can keep a consistent temperature even when the environment around them changes. Animals living in oceans and large lakes are protected from severe and harmful temperature changes. And those properties are just as vital to humans. We are also bodies of water. In fact, we are 60% water. All that water protects us from high and low temperatures, allowing us to survive in the most extreme conditions. Let's review what we know about water so far. It's all around us and inside of us. Chemically, it's made up of 1 oxygen and 2 hydrogen atoms that are held together with hydrogen bonds. It can be a solid, a liquid, or a gas, but it takes a lot of energy to change from one form into another. So what exactly does water do for the human body? Is it more than just a thirst quencher? Water makes up about 60% of an adult human's body weight because it is a critical part of nearly every life system and process. It's in our cells, in our blood, and in our organs. And it has been called the most essential nutrient, more important than vitamins, more than minerals, even more than carbohydrates or proteins. If you are deficient in other nutrients, you might not become ill for weeks, months, or even years. But without water, you'll live for less than a week. It's that important. In this section, we'll go over some of the crucial functions water performs for the body. Water is vital to helping the body regulate its temperature. The human body needs to stay at a constant temperature of 98.6 degrees Fahrenheit. That's 37 degrees Celsius, to keep all its systems running properly. When we are in danger of overheating, our bodies use water to help us cool off. This is called perspiration, or more simply, sweat. When sweat evaporates or transforms from the liquid to the gas state, it cools off the skin. Water helps us fight illness and disease. It is found in lymph, a fluid that's part of the immune system. It helps move white blood cells around so they can fight infections. Water is used to lubricate the joints between bones by creating a soft cushion, like a shock absorber does on a bike or car. In the same way, water protects the spinal cord and keeps the eyes lubricated. One of water's most important functions is helping to run the digestive system. Water helps in the formation of digestive enzymes and juices. It also carries the enzymes that help break down food. To excrete waste and keep us healthy, water works closely with our kidneys. The kidneys are two bean-shaped organs located below the ribs back near the spine. Kidneys maintain the body's chemical balance by filtering waste and excess fluid from the blood. Those wastes and fluids are then passed out of the body as urine. Water is also the basis of our blood. It helps carry oxygen to all the cells in our body, and it keeps our hearts healthy by maintaining blood volume, concentration, and pressure. It's essential to keeping all body's processes running smoothly. To understand just how big a job it is, we must go to the microscopic level. Your body is made of trillions of tiny cells. Inside and outside each one are fluids made of chemicals floating in water. Cells try to constantly maintain the perfect composition of those fluids, depending on what each cell type needs. Water molecules are passed in and out of each cell to maintain that cell's water balance. Imbalances in those fluids can wreak havoc with the body's functions. Think about a cell as a water balloon. Imagine how it would look if it lost all its water. Or what happens if it fills up too much? It might burst. To keep your cells doing their jobs and to maintain a healthy water balance, the body constantly adjusts the amount of water it lets in and out of the cells. Your body sends signals to help you maintain that balance. Thirst, a dry mouth, and sluggishness are signals that your body needs more water. Feeling bloated and frequent trips to the bathroom are signals that you may have had too much water. Let's review. Water plays a crucial role in the function of our digestive system and our major organs, like the heart and kidneys. And even way down at the microscopic level, our cells are constantly working hard to maintain our water balance. Our bodies send us signals to let us know if we aren't getting enough or if we are getting too much water. But exactly how much water should we drink? Now that you know about the critical tasks water performs for the human body, you can see why it is so vital to our health. But just how much water do you need to stay healthy? The amount of water you need changes from day to day, depending on how active you are, how well you are, and how hot it is. The U.S. Food and Nutrition Board offers some basic guidelines. It recommends that the average healthy adult drink 8 to 12 cups of water each day. That's about 2 to 3 liters. Men should drink closer to 12 cups and women closer to 8 cups. Our bodies actually need a little more than that, but we get a little more water from food and from other beverages. Although water makes up 60% of an adult's body weight, it actually makes up 75% of a child's body weight until about age 10. That means water is even more important to children. Children and toddlers should drink 3 to 6 cups per day depending on their weight. Infants usually get water from the breast milk or formula. Caregivers should always follow the pediatrician's recommendation. There are times when we should drink even more than the recommended daily amount. You lose water when you have a runny nose and a fever that makes you sweat. So it's a good idea to drink more fluids when you're sick. Hot weather makes us sweat, so you also need to drink more water if it's hot outside. We know we lose lots of water by sweating, but did you know that we also lose water by simply breathing? The more you breathe, the more water you lose. Exercise makes us hot and makes us breathe heavily, so it's important to drink more water if you're exercising. To get an idea of how much water you need to drink during exercise, weigh yourself right before and right after a workout. Almost all the weight you've lost will be water. For every pound lost, you need to drink about 2 more cups of water than usual. This can help serve as your hydration guide for future workouts and competitions. Remember that staying hydrated during exercise will not only make you feel better, it will also make you compete better. For even the best trained athletes, the competition is over if they start out dehydrated. Physical activity can actually make you less sensitive to thirst, even though you need more water. So if you're exercising or doing physical work, don't wait to feel thirsty before you drink water. If you're sweating, you know your body needs to replace that lost water. Let's review what we learned in this section. 8 to 12 cups or 2 to 3 liters of water is the recommended daily amount for a healthy adult. Exact amounts vary for men, women, and children. There are times when we should drink even more than this amount, like in very hot weather, and after we have lost fluids due to exercise or hard work. Because if we don't stay hydrated, the consequences can be very serious. You've probably heard that when we don't get enough water, we experience what's called dehydration. But what exactly is dehydration? Why does it matter if we get dehydrated? And how do we even know it's happening? Dehydration is what happens when water intake doesn't equal water loss. Here's what happens inside a person's body when they become dehydrated. At first, dehydration stimulates your brain to tell you that you are thirsty. If we don't drink enough fluids and dehydration continues, our bodies will try to compensate by retaining fluids. We will sweat less, and our kidneys will produce less urine. Water moves from inside our cells and out to the bloodstream to maintain our blood volume and blood pressure. As dehydration becomes more severe, our body tissues begin to dry out. Cells can shrivel and malfunction. And it can get worse. When we lose water, we also lose some electrolytes along with it. Electrolytes are chemical elements in our blood and tissues that keep them functioning. Some of the most important electrolytes are sodium, potassium, chloride, calcium, and magnesium. When there aren't enough electrolytes in the blood, water won't move as fast from inside the cells to the bloodstream. So the amount of water in the bloodstream is not quickly replenished. Blood pressure and volume drop. The heart works harder to move blood through the bloodstream, and there may be damage to our internal organs, such as the kidneys, liver, and brain. The main ways we can lose too much water and experience dehydration include sweating, vomiting, diarrhea, burns, diabetes, prolonged exposure to dry air, blood loss from an injury, excess intake of alcohol or drugs, certain infectious diseases, malnutrition, and a simple lack of available clean water. If exercising while dehydrated, our performance is likely to suffer due to low endurance, increased heart rate, raised body temperature, and premature fatigue. Dehydration symptoms usually appear after 1 to 2% of our normal water volume has been lost. First, we feel thirst and some discomfort, and possibly dry skin and constipation. Other symptoms of mild dehydration are decreased urine volume, abnormally dark urine, fatigue and irritability, lack of tears when crying, headache, dry mouth, dizziness, and in some cases, insomnia. At about 5% water loss, urination will be greatly reduced and may become painful. Fatigue turns to extreme sleepiness. Dizziness turns to fainting. Body temperatures rise further while blood volume and pressure sink further. We may experience nausea, tingling in the limbs, and appear to have sunken eyes. Brain cells are particularly vulnerable to dehydration, so confusion is a common indicator that dehydration has become severe. At 10% or more fluid loss, our muscles spasm, our skin shrivels, vision dims, and seizures or delirium may begin. At loss of 15% or more of fluids, the kidneys may produce no urine at all. A severely dehydrated person will fall into a coma and die. So what should we do when we're dehydrated? Drink water or an energy drink with electrolytes. Call a doctor if your symptoms are anything more than mild. Infants and small children are more likely to become dehydrated more quickly because they can lose water faster, and their fluid level requirements are higher. How can you tell if a child is dehydrated? Look for these signs: decreased urination, no tears with crying, less saliva with a tacky texture to the mouth, gray or pale skin color. In severe cases, you also might see an infant soft spot have an unusual sunken appearance. Always call a doctor immediately. The elderly are also at much higher risk for dehydration than the average healthy adult. After age 50, our thirst sensation begins to diminish, and older adults sometimes take several medications, which can further reduce the thirst response, our cue to hydrate frequently. Look for sudden episodes of confusion, a common indicator of dehydration among the elderly. Not drinking enough water can be dangerous, but so can drinking too much. The opposite of dehydration is overhydration, which means the body is carrying an excess of fluids. Drinking large amounts of water does not usually cause overhydration. To exceed the body's ability to excrete water, a healthy adult would have to drink more than 2 gallons of water a day regularly. When overhydration occurs quickly, brain cells are particularly at risk. Confusion, seizures, or coma may develop. Sometimes an overload of sodium prevents the excess water from moving into the cells. Instead, it accumulates around the cells, resulting in swelling in the chest, abdomen, and lower legs. Severe cases of overhydration are called water intoxication. It is rare, but can cause a condition called hyponatremia, which means low blood sodium. Hyponatremia usually happens in one of 2 ways. If we sweat heavily for several hours during exercise or heat exposure, we can lose too much sodium through our sweat. Or, if we drink large amounts of plain water, the kidneys can't get rid of the excess water fast enough, so sodium in the blood becomes too diluted. Nausea, muscle cramps, disorientation, slurred speech, and confusion are early warning signs of hyponatremia. They are often subtle and may be similar to dehydration. Many times, people will drink more water because they think they are dehydrated. But that just further lowers their sodium levels. And like dehydration, severe hyponatremia is fatal. Water intoxication and hyponatremia are most commonly reported among endurance athletes. But people have died from them during events like radio station contests and fraternity hazings that provoked people to drink a lot more water than they should. If you do hard labor, especially in hot conditions, or exercise for longer than an hour, it helps to drink a sports drink that can replenish both fluids and electrolytes. And if you exercise for longer than 3 hours, running a marathon for instance, you must replace your electrolytes. If you don't, you risk developing hyponatremia. During a long race, runners can replace even more sodium by eating pretzels or some other light, salty snack that's high in carbohydrates and easy to digest. Let's review. We've learned the signs and side effects of both dehydration, not getting enough water, as well as overhydration and hyponatremia, getting too much water. Both conditions affect our outward appearance and physical functions down to the cellular level and can be fatal. People who do a lot of hard labor, especially outdoors, as well as endurance athletes, should be particularly alert to their body's signals. Luckily for most of us, water is easy to come by. But have you ever wondered how water gets to your faucet? In this section, we'll discuss where water comes from and how it is treated to prevent the spread of disease or illness. Salt water from oceans cannot be consumed without expensive processes to remove most of the salt. Surface water and groundwater are our most common sources of drinking water. Surface water is found in lakes, rivers, and reservoirs. It supplies the drinking water for most big cities. This is Lake Michigan. It supplies the city of Chicago with drinking water. Because surface water is exposed, it can easily be contaminated or polluted. Groundwater comes from underground sources and is usually pumped from wells. Groundwater can be contaminated if toxic chemicals soak into the ground from landfills and hazardous waste sites. Public water is treated and filtered to remove contamination and pollution. This is why water intake can be a problem in developing countries or even in industrialized countries that experience a natural disaster. In these situations, water supplies are often contaminated or cut off, making clean water hard to get. This can cause extreme, often fatal levels of dehydration in whole populations. A lack of clean drinking water can also lead to widespread illness. Untreated water in lakes and streams can carry bacteria and other microorganisms that spread disease. This is why clean drinking water is often the first thing sent to disaster areas. In order to kill disease-causing bacteria, we turn to science and the periodic table of elements. The most common additive in treated water is chlorine. Depending on local conditions, other additives are used, such as bromine and carbon. Another common additive is fluoride. American cities began adding fluoride to water supplies in the 1940s. The American Dental Association believes water fluoridation led to the dramatic decrease in tooth decay in the United States. However, adding fluoride to water is a source of some controversy. Many argue that the health risks posed by fluoride may outweigh the benefits. All natural water contains some dissolved minerals. These give water some distinct characteristics. For instance, sulfur will make water smell like rotten eggs. Iron can leave rust-colored stains on fixtures. Water that's high in calcium and magnesium is called hard water. Over time, hard water can leave a ring on the bathtub or crusty deposits in a tea kettle. Water that's high in sodium or potassium is called soft water. Some people prefer soft water for its taste or because it doesn't leave stains. But the sodium in soft water can be a problem for people with high blood pressure or heart disease. Let's review. We get most of our drinking water from surface water, lakes, rivers, and reservoirs, or from groundwater, underground sources pumped from wells. Both, however, can become contaminated with dangerous chemicals, or disease-spreading bacteria can contaminate water. Water treatment facilities use additives to remove contaminants and pollution and make it safe for us to drink. All drinking water contains some minerals. Too much of these minerals can result in hard or soft water. But beyond our faucets, how else can we get the water that we need? We now know the ill effects caused by not drinking enough water. The good news is there are lots of ways to make sure you get the water your body needs to stay healthy. But all those choices can be confusing. In this section, we'll go over some of the popular beverages available. We'll try to help you understand their benefits and drawbacks. Plain drinking water is the best way to hydrate your body. But there's some water in every liquid you drink. There are even many foods, like this apple, that provide us with some of the water that we need. Crunchy vegetables such as cucumbers, celery, lettuce, and carrots are often made of 75 to 90% water. Watermelons, grapes, and oranges are juicy fruits that are full of water. You can also get the nutrients that you need from beverages besides water. One of the best sources is non-fat or low-fat milk. But what about other beverages we drink every day? What kind of effects do they have on our bodies? Coffee and sodas contain water, but they also contain caffeine. Caffeine acts as a diuretic, which means it stimulates the production of urine. So even though you are consuming water by drinking soda, the caffeine may stimulate your kidneys to excrete extra liquid. Caffeine boosts blood pressure and heart rate, which can be dangerous for people with heart conditions. Caffeine also creates some acid in our digestive system, which can aggravate ulcers and acid reflux disease. Still, some experts say that drinking caffeinated beverages is an acceptable way to get some of your daily water intake. Energy drinks contain a lot of caffeine, so they can have the same effects on the heart as coffee. They're often full of natural and added sugars, so are sodas and juices. Choosing juices, even the ones without added sugars, can be tricky because there are so many kinds with different benefits and different amounts of sugar. Many juices, like orange and tomato, are filled with vitamins and minerals. But tomato juice often has high levels of sodium, and 1 cup of orange juice can have both the juice and the sugar, from 2 to 3 oranges. That's a lot of sugar to drink all at once. Sugary drinks can contribute to tooth decay. Many are also what we call empty calories. This means by drinking them, you are getting more calories than nutritional value. All these beverages can contribute to your daily water needs, but they have other effects you should consider before making them your main source of hydration. A nice, cool glass of water is usually your best alternative. Thought you've had enough choices for water? What about the different types of drinking water available? Even when you want plain drinking water, you have options. Is there a benefit to drinking bottled water over tap water? Are all bottled waters the same? Let's take a look at some of the differences in the water that people drink. We already know that cities in industrialized countries treat their water supplies to eliminate certain impurities. But some people do their own filtering at home. People considering purchasing a home filter can research what's in their local water supply to help decide which system is right for them. In the United States, the Environmental Protection Agency's website is a good place to find local drinking water information. If you are planning a trip to other countries, find out about their drinking water before you go. Whether here or abroad, many people choose to drink bottled water instead of drinking local tap water from their faucet. In fact, the average American drinks more than 20 gallons of bottled water each year. We've spent more than $15 billion on it. What's in it that's so appealing? The Food and Drug Administration sets standards for bottled water. Those regulations are the same as the ones set for public water systems. There are dozens of brands to choose from, many with claims about purity. It's up to the consumer to decipher those claims. So let's take a closer look. Some bottled water comes from groundwater sources like springs or wells. Sometimes bottled water comes from the exact same sources as tap water. It might also be purified with chlorine, just like tap water is. In other words, sometimes bottled water is exactly the same as tap water. In fact, 25% of bottled water is estimated to come from municipal sources, the same places cities get tap water from. You can see where any bottle of water came from by looking at its label. Companies are required by law to state the source of the water they bottle. There are some drawbacks to drinking bottled water. Despite being regulated by the FDA, contaminants like arsenic have been found in many brands of bottled water. So there's no guarantee it's any more pure than tap water. The only guarantee is that it will be more expensive, as much as 200 times as expensive as public water. Let's review. We can get the water we need from other sources besides drinking water. Many foods, especially juicy fruits, can provide us with water. All of the beverages that we drink contain some water, but it's important to choose healthy options. Many popular drinks contain caffeine and lots of sugar and artificial sweeteners. These can have negative side effects that outweigh the benefits of the water they provide. People who want to get rid of additives and impurities in drinking water sometimes choose water filtration systems for their homes. Bottled water can give us the nutrients that we need without added sugar or caffeine. But many people purchase bottled water due to claims of purity and exotic natural sources. The consumer should beware, however, because some of these products use the exact same water that people can get from their taps. Let's review what we've learned in this program. Water is the most important nutrient to every living organism on our planet. It's all around us and inside of us. Our bodies are about 60% water. 2 atoms of hydrogen connect to 1 atom of oxygen with hydrogen bonds to create a water molecule. Because of these bonds, water is slow to change from cold to hot. So that 60% helps people survive in both freezing and extremely hot conditions. Water plays an important role in every single function in our bodies. Our life depends upon its proper balance. But our bodies send us signals when we aren't getting enough or if we're getting too much water. We learned that our drinking water goes through several stages and must meet government standards before it reaches our lips. Bottled water has to meet the same standards, and some might even come from municipal sources, just at a higher price. Make sure you read the labels if you want to know what you are buying. We can get water from many kinds of beverages and even some foods. So, the next time you quench your thirst with some water, or even take a bite from a juicy apple, remember that you are providing your body with its most essential nutrient.